Hello, welcome to this video tutorial. This tutorial serves to help with the physics homework freefall acceleration problems. Try to use this as a template for how you can solve your problems. Well, let's begin. There are going to be a total of 6 problems we're going to work on today. The first 4 are called dump tower 1, 2, 3, and 4. Then we'll take a look at what happens when we toss up an object with positive initial velocity upwards, high school toss level 1, and high school toss level 2. So let's go ahead and begin. Starting with dump tower level 1, go ahead and enter your name into the program, and let's begin. Now, it's going to start. It says, when you click on the ball, you will use the information that is provided to find the gravitational field strength of the planet. That means the acceleration due to gravity and the speed. Remember, no negatives. So no, we're not going to put negatives for the acceleration due to gravity, even though it is downward. And we're not going to put negatives for the speed because speed has no negative. All right, here we go. So let's press on the ball. We're going to let it fall. And we're going to take some data. Now, the first thing I notice is that the ball is dropped, which means it starts from rest. Okay, so let's put in our data. We know the displacement is negative. In my case, it's negative 313 meters because that's the height of the building. So I'm going to go to, we're in problem number 1, mind you. And I'm going to enter in my table. Now notice all the tables say delta x. Well, let's make a small correction there. Instead of delta x, we're going to be dealing with delta y. So just keep that in mind. Okay. Delta x is horizontal displacement, delta y is negative displacement. So my delta y was negative 313. My initial velocity is 0. I don't know my final velocity upon hitting. I have to find the acceleration due to gravity, and the time was, for me, 11.421 seconds. Okay, so enter all that in. What we're going to do is we are going to find the acceleration and the final velocity. Now, let's go ahead and find the acceleration first. Okay, now the way we can do that, we're going to split our problem into 2 parts, okay? The way we can find the acceleration first is if we focus on an equation that has displacement, initial velocity, acceleration, and time. Pause the video for a second and see if you can find that location for you. Okay, so the equation that we're going to be working with would be delta y see, delta y equals v naught times t plus 1/2 at squared. Okay, now since the object is released from rest, I know v naught times t is equal to 0. So the equation I get is delta y equals 1/2 at squared. Well, to solve for a, we're trying to find a, mind you, you need to start by multiplying by 2 to get rid of the half. And then we can divide by t squared to get rid of the t squared. That's how we can get a by itself. So a is going to be 2 times your displacement, which is, now here's the thing. The actual displacement is negative 13. But since it's not asking you for negatives, negative acceleration, nor negative velocity in the actual program, then what you're going to do is just enter the absolute value of the displacement, just 313, height of the building, divided by your time, which in my case is 11.421 seconds, squared. Put that in your calculator. I'll put mine in mine. I'm getting an acceleration of about 4.8 meters per second squared. 4.799, I'm just rounding up to 4.8. Now, to find the final velocity, that could be like as simple as using equation number 8. V equals V naught plus A times T. Well, V is 0. We just found A, so it's going to be 4.8 times the time it took to fall, which in my case was 11.421. And I'm getting a speed of about 54.8 meters per second. Well, let's put this into the program and see how we did. All right, and there we go. Hopefully you were able to get question number 1 correct as well. If you did, well, let's move on to question number 2. Dump tower level 2. Nice little play on words there, isn't it? Well, you can see we have a height of the tower of 129 meters. Okay. We need to, it says using all the information provided to find the time. This time we have to find the time and we have to find the final speed. So let's list our information. We know the displacement is 129. Well, in my case, write down your displacement. Mine is negative 129. Now, I think in my calculations, I probably won't need to use the negative, but I'm still going to put it anyway. My initial velocity is still 0 because it's released from rest. My final velocity, I don't know it. That's going to be a question mark. Now, my acceleration, okay, it's not asking me to find an acceleration on some planet. So I'm assuming the acceleration due to gravity. And in this particular lesson, I know I told you in class you can use negative 10 meters per second squared. However, I think in light of this program, let's be a little bit more precise about it, and we'll go ahead and use negative 9.8. Okay, meters per second squared. The time is something that you are finding also, so time should be a question mark. Okay, so go ahead and draw a line so that you can separate the two things you're going to solve for. We're solving for V final and time. Okay, well, what if we find the time first? That means I have displacement, initial velocity, acceleration, and time. Pause the video and see if you can figure out the right equation to use. Well, if you're solving for time, that would be displacement as a function of time, meaning equation number 10. Delta y equals v naught t plus 1/2 a t squared. Okay, again, v naught t is 0. So delta y equals 1/2 a t squared. Well, we start off solving it the same way we did with number 1. We're going to multiply by 2. But this time, you have to solve for time, which means you have to divide by a. All right, now if I rewrite what I have here, I've got t squared equals 2 delta y divided by a. Well, the opposite of a square is a square root. So I'll square root both sides like this. And I get t, oops, what color? I get t is equal to 2 times my negative 129 meters over my negative 9.8 meters per second squared. The negatives will cancel. And so 2 times, go ahead and enter your values. I'll enter mine. So I'm going to go 2 times 129 divided by 9.8. And then I'm going to take the square root of that. Now I'm getting a time of about 5.13 seconds. Okay, go ahead and calculate your time. And then we need to find the final speed. Well, again, just like in question number 1, I can come back with the equation V equals V naught plus AT, equation number 8. And again, V naught is 0 because you're dropping it. So just go ahead and plug in. We're going to go negative 9.8 times the time that you got. I got 5.13 seconds. Okay, now the velocity The velocity is going to be negative because the object is headed downward. Okay. However, the speed is just going to be the absolute value of that, which in my case is going to be 50.3. Go ahead and take a moment to enter your values in and let's see how we do. All right, and there we go. You can see my actual and predicted values match up. Hopefully you were able to get question 2 correct yourself. If so, let's move on to question number 3. What's your name in the program? Now it says you're going to click on the ball to drop it. So let's do that. It says you will use the information that is provided to find the height of the tower and speed. No negatives. All right, so we're looking for height and speed this time. So we know the time is 4.886 seconds. Well, in my case, it is. Go ahead and write yours. 4.886 seconds. I know V naught is 0 because it's dropped from rest. I'm looking for the height of the tower, and I'm looking for the final speed. The acceleration, again, we're going to use negative 9.8 meters per second squared. All right, and again, go ahead and draw a line to separate the two halves of your work. Let's see, what can we solve for first? Well, how about this? I like this grouping of variables here. What if we solve for final velocity first? Because if we do that, we can use equation number 8. V equals V naught plus A times T. V naught is 0, and V would be negative 9.8 times 4.886. Okay, now let's see, 9.8 times 4.886. We get negative 47.88 meters per second. Now that's the velocity. The speed, right, would be just the absolute value of that, 47.88 meters per second. No negatives. Okay, now the second half of the problem, we're looking for displacement. There's a bunch of ways we could do that. We could either use delta y equals v naught t plus 1/2 at squared. Okay, or you could end up using delta y equals v plus v naught over 2 times t. Because now you've got final velocity right here. So go ahead and work whatever one you want. I'm going to practice with the first equation just to get some practice with it, just to change it up a bit. But both equations do work. Now, if I do plug into this equation, I know V naught T is going to cancel because V naught was 0, the ball was released from rest. And delta Y, my displacement, is going to be 1/2 times my acceleration, negative 9.8, okay, times my time. My time was 4.886 seconds. Put that in your calculator and let's figure out our displacements. Now, to do this, you need to square the time first, then multiply that times 9.8, hit equals, and then divide by 2. I'm getting a displacement of about negative 116.98 meters. Okay, the negative just means that the ball is falling that distance. So the height is just the absolute value of that, right? 116.98 meters in my case. And there we go. Hopefully you were able to get question 3 correct as well. Okay, if so, let's move on to question 4. Okay, halfway there, we're doing good. Put your name into the program. Now we're going to use all the information provided to find again the height of the tower and the time to fall. So let's go down to question 4. We are finding the displacement, which is going to match the height of the tower, and the time of fall. Those are our two unknowns. Okay, let's see what we do know. We know, okay, down at the bottom, we're given a new acceleration due to gravity. In my case, it's 6.1. Go ahead and write yours down. So negative 6.1. It's negative because it's downward acceleration. And my final velocity is 29.01. Releasing it from rest, so 0, but 29.01 is my final velocity. Okay, draw a line to separate the two halves of your work, and let's get started. I'm thinking I'm probably going to find time first. I mean, honestly, it doesn't really matter which one you find first, but I'm going to find time first. And the reason why is I like this grouping of variables right there. Like that's pretty good. And that allows me to use equation number 8, right? Which is V equals V naught plus A times T. V naught is still 0 because the ball is dropped. And to solve for T, I'm just going to, well, divide by A. So T, the time, is going to be your final velocity divided by A. Okay, now the velocity technically would be negative, just like the A would be negative because they're both downward, but you'll notice the negatives, they cancel anyway. So it really, at the end of the day, it doesn't matter. 29.01 meters per second over 6.1 meters per second squared. Go ahead and take a moment to put that in your calculator. Okay, I'm getting a time for me about 4.76 seconds. All right, now I got to find my height. I'm going to try and find height a slightly different way. I'm going to use equation number 11, my displacement, V plus V naught over 2 times T. V naught was 0, so my displacement is going to be my final speed, 29.01, over 2 times 4.76. Okay, so if I go 29.01, take half of it, times 4.76, I get a downward displacement of 69.04 meters. Okay, go ahead and take a moment to calculate yours and see what you get for a height of your building. And let's enter our values into the program. All right, and there we go. Again, hopefully you were able to get question 4 right as well. If so, on to question 5. Put your name into the program. Now, in this one here, you're going to have an object tossed upward, which means it will have positive initial velocity. Okay, the gravitational field of the planet and the height of the building. You have to find the time it takes for the object to reach the ground, the speed when it reaches the ground, basically the impact speed, the speed right before it hits, and the maximum height at which it gets to above the surface. So let's take a look at how we can do this one. And we're going to do this in a couple different parts. I'll show you how. Okay, so for me, I have a okay, so the following I'm gonna basically draw in that information that I have there. So I've got V naught is 15. Right? And it is giving me the mass of it. I don't suspect that I'm going to need that for a kinematics problem, but I'll just record it anyway. 2.2 kilograms. The height of the building appears to be 23.1 meters in my case. And the height at which the ball will rise to, we don't know. Okay. It's just, we know it goes upwards. And the gravitational field, we are told in my problem, G, is 7.57. Now, something to note. Normally, we've been writing this unit as meters per second squared. Well, another way to write the gravitational field or the acceleration due to gravity is you can write it in gravitational field units, which would be newtons per kilogram. That's just a new way of writing it. Please note that 7.57 newtons per kilogram is the same as 7.57 meters per second squared. I know these don't look like equivalent units, but they actually are. All right, so we have our information. We have to find the time it takes to be in the air. We have to find the impact speed when it lands, and we have to find the max height from the ground. We're going to treat the max height from the ground as a completely separate problem, and I'll show you why. First, let's find the speed of the ball when it reaches the ground and the time it took to reach the ground. So let's go ahead and split this into two. And here's how we're going to do that. Okay, I'm going to use this chart for the whole path. So my displacement, the ball is going to go negative 23.1 meters because that's how far it will fall from the tower. It's being thrown upwards, in my case, with 15 meters per second. We're looking for the final. Okay, my acceleration is negative 7.57 meters per second squared. And the time is something I'm looking for. So go ahead and break this in half. And here's what I'm seeing. I'm seeing that I can actually solve for the impact speed first. Watch. If I look at this group of four variables here, look at that. I just simply need an equation to help me find V final. So I'm looking for an equation that has V final, V initial, acceleration, and delta Y displacement. That, guys, would be V squared equals V naught squared plus 2 times A times delta Y. Notice I'm just writing delta Y instead of delta X. Don't cancel out V naught. Remember, V naught has a value this time. It's upward velocity. Okay, so don't cancel it like we have been. But this is pretty simple. Just go ahead and solve for V by taking the square root of both sides. Now be careful. One common mistake I see is students want to take the square root and cancel the square. That is not a thing because that right there, that plus, means that this whole discriminant underneath the that whole radicand underneath the radical is not in factored form. And when it's not in factored form, you can't just haphazardly or randomly cancel stuff. So when in doubt, don't. Just plug in. So we've got V equals the square root of, put in your value, mine is 15. So we'll go 15 squared plus, okay, now I'm going 2 times your acceleration. Mine was negative 7.57 times your negative displacement. That means the height that it fell from. Mine was 23.1. Okay, and with that, notice, guys, notice little details matter. Notice the negative and the negative multiply to make a positive. So that means you will ultimately be adding 15 squared to whatever this is. Okay, well, in my case, 15 squared. Okay, so I'm going to go ahead and figure that out. I'm going to go 15 squared plus parentheses 2 times 7.57 times 23.1, close parentheses, and I have the radicand, then I just need to take the square root of that number. Okay, and I get an impact speed of about 23.97 meters per second. Okay, now to find the time it takes, I can just come back to equation number 8 now, because I've got the final speed. Now, how do I solve for time? I'll need to subtract B naught and divide by A. So V minus V naught equals A times T. Divide by A. Okay, and time is going to be your velocity. Okay, now keep in mind, um, your velocity is negative. You got to be careful with this. This was a speed answer, but this is a velocity calculation. So be careful with the details. The velocity is technically negative 23.97 minus whatever your initial velocity was. Mine was 15, divided by whatever your acceleration is. Mine is negative 77.57. Okay, I'm going to put that in my calculation here. So negative 23.97 minus 15 divided by negative 7.57. Oops. I'm getting about 5.14 seconds. Okay, so that's what I have for my first couple values. So I've got 23.97. I've got 5.15. Okay, and now to do max height, I'm going to do essentially a completely separate problem. Okay, and here's how this problem is going to be separate. I'm only going to focus on the ball. See, here's the top of the tower. I'm going to focus on the ball getting to its max height. Okay, so I've got the tower height itself was 23.1. So I will add whatever displacement I get that I'm looking for here. I will just simply add that to whatever the height of the tower is, in this case, 23.1. All right. Now, what do I know? Well, I know that this is 15 meters per second in my case of upward speed. But I also know that at the highest point, the final velocity drops to zero, because at the highest point, the object is going to stop to turn around and go the other way. So set your V final equal to zero. Your acceleration is whatever it was before. Mine is negative 7.57. And you don't know what the time is, but guess what? You don't need it, because you guys can use that group of variables there. And the equation you want that has delta y, v, v naught, and a in it would be v squared equals v naught squared plus 2a times delta y. V cancels because v is 0, so v squared is 0. So I get 0 equals v naught squared plus 2 times a times delta y. And remember, guys, we are solving for delta y so that we can add it to the height of your building. So in order to do that, I need to get rid of v naught squared first. So what I'll do is I'll go ahead and subtract v naught squared to the left. And when I rewrite this, I get negative v naught squared equals 2a delta y. My last step would be to divide by 2a. And my displacement, delta y, is going to be negative, whatever your speed was, mine was 15, over 2. And notice the negative is not being squared, it's outside, so you have to account for the negative. But watch, it will account for itself. 2 times your negative acceleration, and your negatives will cancel. Okay, now just don't forget to add this to the height of your building. Mine is, well, 23.1. So make sure you add whatever this is to the height of your building. So 15, I'm going to go 15 squared divided by, open parentheses, 2 times 7.57, close parentheses, and I'm going to add that to 23.1, and I'm getting a max height of about 37.96 meters off the ground. Well, let's enter that in the program and see how we did. It's going to run the program there. It's going to go up, go back down again. So far, I can see my max height is right on, and I'm getting closer to a good time. And there you go. Right on perfect exactly with every single value. It just takes a little bit of detail, but a lot of organization, and you'll be able to get this right as well. Well, if you got question number 5 right, on to the final question. Number 6, high school toss level 2. Now, similar question, you're going to be given an upward velocity, okay? But in this question, you have to find the velocity in two locations. Location 1 and location 2. Location 1 will be above the height of the building. Location 2 will be when the ball is on its way back down below the height of the building. Okay. And then the last part, of course, is to find the max height off the ground. But we already practiced doing that. So we know how to find the max height as its own separate problem. Okay. All right, let's dig into this. So I'm gonna go ahead and now I'm gonna use my acceleration as negative 9.8. Okay, because remember, we don't want to round up with this program. It'll make it a little more accurate if you keep it at 9.8. So my initial velocity is 24.3. Okay, so my delta y displacement, whoopsie. There we go. Is 24.3 meters per second. The displacement, well, the displacement, it's going to be different displacements. Okay, watch. I'm going to actually use this table twice. You'll see what I mean. Okay, delta y, v naught, v, a, and t. Okay, so I'm going to use the table twice. I'll show you why. So my delta y for part 1, right? My displacement is 16.8 meters higher than the building. So it's positive 16.8, oh, wrong table, sorry. So this is going to be level 1. This is going to be location 2. So 16.8 positive meters of displacement above the building. Okay. I don't know what the velocity is there. That's what you're trying to find. You're trying to find that. Okay. That's your ultimate unknown. Okay. Negative 9.8 is going to be your acceleration. And time you don't know, but you know what? Time doesn't matter necessarily. By the way, the displacement for your second one is going to be negative because notice location 2 is below the height of your building. So to figure that out, okay, my height of building is 19.4. So I'm going to go and label some stuff. So this is 19.4 meters from here to there. And then location 2 is 10.5 meters above the ground. So I'm going to label that down here. Well, your displacement, guys, for location 2, this displacement right here, that's just going to be the height of the building minus the height from the ground. So if I go 19.4 minus 10.5, right, that means the ball is falling negative 8.9 meters in my case. Okay, so just make sure you account for that displacement as being negative because it will be below the height of your building. Now, check this out. In order to solve for the speed at those locations, use this group of variables there that does not involve time. And in doing so, you can actually find the, and we'll split this box up into two, okay? I know there's another box right here, but that's fine. We've already filled it out twice. Okay, and what we're going to do is we're going to fill it out for location 1 and location 2. Okay, and for all we can use the equation that says v squared equals v naught squared plus 2 times a times delta y. Again, don't cancel this. We're using the same equation we used in question 5, right? We square root both sides. And v equals the square root of, plug in your values. For me, it's going to be 24.3 squared plus 2 times, okay, now negative, I believe I have to use negative 9.8 in this one. Yes, negative 9.8 times my positive displacement to position 1 is 16.8 meters, I believe. Let me just double check that. Yes. Okay, so I'm going to punch that into my calculator and I'm going to get a value for the speed at level 1. I'm going to do the exact same thing for level 2. V equals the square root of V naught squared plus 2 times A times delta Y. So as I plug into that, I'm going 24.3 squared plus 2 times negative 9.8 again. The only difference is at location 2, my displacement is now negative 8.9 meters below the height of the building. So negative 8.9 meters would be my delta y. Notice the two negatives there, so I'm going to be adding that to v squared when I put that in my calculator. So pause the video and go ahead and find your speeds at location 1 and location 2. All right, so those are the values that I got, okay, at those different locations. Now, to find the max height, remember, we have to treat this as a completely separate problem where here's the height of your building, okay? There's the height of your building. In my case, the building is 19.4 meters high. The ball goes upwards, reaches a maximum height. Okay, so I got to take this displacement, delta y, and I have to add it to 19.4. But remember, at the top, v final equals 0, right? V final equals 0. Put in your initial velocity. It's the same as it's been the rest of the problem. In my case, it's 24.3. I'm looking for that. Negative 9.8 is my acceleration. I don't know time, but I don't need it because I'm going to use the same equation. But this time, instead of solving for v, I'm going to solve for delta y. Okay, so v squared equals v naught squared plus 2 times a times delta y. And if we treat this like its own separate problem where the velocity is 0 at the top, we'll cancel v. We get 0 equals v naught squared plus 2 times a times delta y. Let's subtract v naught squared to both sides. We get negative v naught squared equals 2a times delta y. Divide by 2a, right? And the only thing left to do, okay, you've got your negative v naught squared over 2a. You just have to remember to add it to the original height of your building. My height of my building is 19.4 meters. So just remember to add it to the original height of your building to get the max height off the ground. All right, let's plug in our numbers. So for me, it's negative 24.3 square it over 2 times negative 9.8. Okay, the two negatives, the negative here and the negative there will cancel, so you're good to go there, plus the height of your building. All right, so let's find the overall max height. All right, I'm getting a max height of about 49.53 meters in my case. Well, I'm going to go ahead and put in my values and see how I did. You go ahead and put in your values. Let's see how you do. Okay, it's going to run the program. Already I can see my V1 is right on. Okay, it's on its way down. Got max height. My max height is pretty close. And my V2, pretty good to go. Okay. Oh, sorry. Try again. Well, man, I was close, but I forgot to put the negative. Wow. Hey, this is why we do the work, right? This is why we do the work because it's really easy to make those mistakes. So since the velocity at position 2 is downward, it's negative velocity. All right. Well, you know what? That's going to be very easy for me to fix this because I just need to reset, get some new values, and get this corrected. So I'm going to leave my work intact, and I'm just going to delete the numbers and put in the new values. So that's okay. It happens. All right. So 20.4 is my velocity. Let me make a few changes along the way. So this is 20.4, 20.4. Delete the speeds in there. Okay, I'm going to delete the, okay, my other ones, 14.4. So 14.4 meters high. And for location two, it's 8.1 meters subtracted from 12.2 in my case. So 12.2 minus 8.1 is a negative 4.1 displacement. Okay, so I've got that squared away. I just got to calculate it. And then to finish my problem off here, let's see, 20.4. Fix that. Okay, 20.4. Everything else seems to be intact. So all I need to do is change the height of the building, change my initial velocity, and that's going to change my max height. Okay. So that's why if you get it wrong, guys, don't be discouraged. Okay. Yeah, it doesn't feel good to get it wrong. I get it. But at the same time, look how it doesn't really take me a whole lot of time to fix it. Okay. I just didn't, you can see that my calculations were very close, so I was right on, but I wasn't right on enough. So that's okay. Keep going until we can't get it wrong, right? So my speed is 20.4. Okay, so we're gonna go 20.4. So I'm gonna do max height first. Okay. Oh, my height of my building was 12.2. So I gotta add that to 12.2 meters. All right, so I'm gonna go 20.4 squared divided by open parentheses 2 times 9.8, close parentheses, add 12.2. I'm getting a max height of about 33.4. Okay. Let's take a look at my velocities. Okay. I wish I had read that more carefully, right? It didn't say speed this time, it said velocity, so I got to count for positive and negatives. Not a big deal. Okay, so now we're going to go, let's see, 20.4 squared minus open parentheses 2 times 9.8 times 14.4 quantity squared. And I'm going to square root that. Okay, so I'm getting a positive 11.57 meters per second upward at this position here. Okay, and then on the downward side, we're going to go 20.4 squared plus this time, open parentheses, 2 times 9.8 times 4.1, close parentheses, second square root, second answer. And for this one, I'm getting negative 22.28 meters per second. Let's try this. Gonna run the program. So far I can see my V1 is pretty good. My max height is pretty good. It all comes down to my V2. And there we go. I got it right this time. So everything in my incorrect answer had to do with a negative direction for velocity not being placed in there because velocity 2 should be going downward instead of upward. So, hey, great learning lesson, right? We all make mistakes, even your teachers, right? In any event, I hope you found this tutorial to be helpful in solving your free fall acceleration homework problems. Thank you. See you next time.